In the beginning, there is not a wall but a question. We call it the edge of the universe, as if a traveler might one day reach it and place a hand on its cold, final surface. But the farther we peer into the dark, the less we find that resembles an edge at all. The light that reaches us has been stretched so thin by the universe's ceaseless expansion that it arrives as whispers, not beams. Ancient photons, older than every star we see. They mark not an ending, but the fading of vision. Beyond that, the universe continues, unseen and perhaps unimaginable. From the vantage point of Earth, we are surrounded by a cosmic sphere roughly 46 billion light-years in every direction. Not because the universe ends there, but because light from anything farther has not yet reached us since the first flash of creation. This limit is called the observable universe. It is less a wall than a moving horizon, retreating as we advance. We live inside a bubble, a luminous sphere cut out of an infinite, or at least unbounded expanse. Everything we know, every star, every galaxy, every dream of life, drifts inside this thinly lit shell. Beyond it lies a darkness we cannot yet touch. The paradox is unsettling. The universe has no center. It is expanding everywhere at once, so no matter where you stand, it looks as though you are at the center of a growing sphere. Yet this very expansion sets a limit to what we can observe. We look outward in every direction and see the same pattern. Galaxies rushing away, their light stretched redder and redder, until at last it fades into the faint glow of the cosmic microwave background. The horizon is not fixed. It is racing away from us faster than light, carrying with it countless galaxies whose ancient light will never reach our eyes. Imagine standing on a lonely shore at night, watching the ocean recede into black fog. You sense that beyond the mist lies more ocean, more shores, more worlds. But no signal returns from that distance. In a similar way, we live at the shore of our own visibility. We are not at the center of the cosmos, only at the center of the part we can see. The thought is both liberating and suffocating. Liberating, because it suggests there is vastly more beyond our reach. Suffocating, because we may never cross that threshold. We are cosmic castaways, our island of sight surrounded by an unending, unlit sea. Early astronomers once imagined the edge as a physical barrier, perhaps a crystalline sphere or a finite vault. Modern science has erased that comforting picture. There is no shell we can break, no final wall. Instead, there is the strange geometry of space itself, which can stretch so fast that distances grow beyond the reach of even light. In this way, the edge is not where the universe ends, but where the universe begins to outrun us. As telescopes grew more powerful, they reached deeper into time as well as space. The farther we look, the younger the universe becomes. Galaxies appear more fragile, more chaotic, less assembled. Beyond them, light itself thins until we meet a great, uniform glow. The cosmic microwave background. This radiation is the oldest light we can see, released when the universe was barely 380,000 years old. Before that moment, the cosmos was an opaque fog of plasma. We see no farther, not because nothing was there, but because the light from that earlier epoch could not travel freely. That glow is like the faint embers of a distant, dying fire, stretched across the entire sky. It is silent testimony that our bubble of vision opens not onto nothingness, but onto something even older and perhaps vaster. Each photon of that background has traveled for nearly the entire age of the universe to reach us, carrying the fingerprint of conditions that existed long before stars and galaxies arose. It is tempting to think of the observable edge as a frontier, an inviting line to be crossed. But the truth is stranger. Because of the accelerating expansion of space itself, regions of the universe that are now visible will one day slip away beyond our horizon. The edge is not static. It is receding, retreating faster than any ship or signal can pursue. The more we learn, the more we realize that the universe's grandest vistas are being pulled forever out of reach. This realization presses upon the mind with a quiet dread. We are used to horizons that can be approached. A mountain range seen across a plain, a distant coastline revealed as we sail closer. The cosmic horizon is different. It is not a limit of travel, but of knowledge. It is as if the book of the universe is infinite, but we are allowed to read only the few opening chapters before the rest is snatched away. And yet, even in this limitation lies a strange hope. The horizon is not a fixed boundary between being and nothingness. It is the shifting seam between what we can know and what remains hidden. As time passes, light from slightly more distant regions reaches us. We learn a little more, and the bubble grows. But at the same time, the relentless expansion carries away distant galaxies faster than their light can keep up. Some chapters of the cosmic story are forever closed to us. We gaze at the cosmic microwave background as if it were a veil, half expecting to glimpse a shape moving behind it. We measure its minute variations, mapping ripples no thicker than 1 part in 100,000. Because these ripples hold clues to the great unseen structure beyond. The pattern is not random. It is a fossil record of sound waves that once rippled through the young universe. These faint tremors whisper that what lies beyond the horizon is not empty, but full of structure, as rich and intricate as the part we inhabit. Here the story shifts from pure awe to the first hint of evidence. The background radiation is not merely a glow, it is a code written in temperature and polarization. Decoded, it points to a cosmos that is much larger than the sphere we can observe, perhaps infinitely larger. It tells us that the part we see is a small sample of something grander, shaped by the same primordial forces. The more carefully we study those ancient photons, the more we feel that we are peering through a keyhole at an immense and unfinished cathedral. We do not know how far the cathedral extends, how many wings or towers it hides, but the faint patterns we can see hint at design on a scale that dwarfs our imagination. We return to the paradox. The farther we look, the less we see, until at last we meet the afterglow of the birth of everything. That glow does not close the story, it opens it. For it tells us that the edge of our vision is not the edge of the universe. It is only the beginning, the visible rim of an unfinished map. And in that knowledge there is both humility and excitement. Humility, because we must accept that the great bulk of existence is hidden from us. Excitement, because the edge we face is not a final wall, but a moving frontier. The observable universe is like the candlelit circle of a traveler in a vast, dark forest. Beyond the reach of the flame lies more forest, more paths, perhaps more travelers. We have traced the circle as far as present tools allow. We have seen galaxies billions of light years away, and we have read the faint script of radiation from a time before galaxies existed. We know now that what we call the edge is not the end. It is a threshold, a beckoning line, and its retreat reminds us that the universe's true vastness lies always just beyond our sight. This is where our journey begins, at the edge that moves away from us, faster than light, promising that there is always more beyond the horizon than within it. The next steps in our exploration will ask what that more might be. Other cosmic domains, new laws of nature, perhaps even answers to the oldest question of all: why there is something rather than nothing. But for now, we stand at the shore of visibility, staring out across a cosmic ocean whose farthest waves will never reach us, and we realize with a shiver that the edge of the universe is, in truth, just the beginning. In the beginning, there was no stage on which the story could unfold, no vast emptiness waiting to be filled. There was only a seething potential, a restless tension without space or time to contain it. Then, in an instant far shorter than the blink of an eye, the universe ignited, not in the sense of a fireball erupting into a void, but as the sudden birth of the void itself. Space swelled out of nothing. Time began to tick where no clock had ever ticked before. This is the first paradox of the cosmos. Everything we know, from the largest galaxy to the smallest atom, emerged not into a pre-existing arena but brought the arena into being. With it, the earliest moments of this new reality were ruled by a phenomenon we call inflation, a runaway expansion so swift and overwhelming that in a fraction of a second regions, once close enough to touch, were driven unimaginably far apart. Picture a speck smaller than a grain of sand swelling to a scale larger than the part of the universe we can now observe, all before the infant cosmos was even a trillionth of a second old. The vacuum itself, endowed with energy, pushed outward faster than any explosion, smoothing out wrinkles, scattering quantum fluctuations like the seeds of future galaxies. Inflation was not a burst of stuff into empty space. It was the eruption of space itself. When inflation slowed, the newborn universe was still hot and dense, a roiling sea of particles and radiation. Over eons, it cooled and thickened into the first hydrogen and helium, then condensed under gravity's persistent pull into stars and galaxies. These glowing lanterns, clustered into vast filaments and walls, marked the arrival of structure in a cosmos that had once been almost featureless. Yet even as structures formed, the underlying space between them continued to stretch. The idea that space itself can expand is not an intuitive one. We are used to seeing things move through space, not space moving itself. But Einstein's theory of general relativity teaches that space-time is flexible, like an invisible fabric whose curves and stretches dictate the motion of matter and light. In this picture, galaxies are not projectiles hurled outward from a central blast. They are like distant buoys drifting apart because the ocean beneath them is swelling. We know this not by conjecture, but by watching the light of distant galaxies. The deeper into the universe we look, the redder their light appears. This is not the redness of a hot ember, but the sign of light waves being stretched as they travel through an expanding cosmos. Like the pitch of a siren dropping as it speeds away, the color of starlight shifts to longer wavelengths. In the 1920s, Edwin Hubble measured this redshift and showed that galaxies everywhere are receding from one another. His discovery revealed that the universe is not static, but growing, and it turned our conception of the cosmos from a fixed stage to a restless, unfolding story. This discovery carried a deeper implication. If the universe is expanding now, it must once have been smaller, hotter, denser. By tracing that expansion backward, scientists realized they were approaching a beginning, a moment when space and time themselves sprang into being. The cosmic drama did not start upon a ready-made stage. The stage and the play are one. For much of the 20th century, astronomers believed that expansion, though vigorous, would gradually slow as the combined gravity of all matter tried to pull the cosmos back together. They imagined two fates, either endless slowing toward a static state, or, if gravity were strong enough, a future reversal into collapse, the so-called Big Crunch. But the universe held a surprise that would shake cosmology to its core. In the late 1990s, teams observing distant Type Ia supernova, exploding stars that serve as cosmic distance markers, discovered that these stellar beacons were dimmer than expected. The galaxies hosting them were not just fleeing. They were fleeing faster than they should have been if expansion were slowing. The universe, it seemed, was not decelerating at all. It was accelerating. This revelation was as jarring as discovering that a tossed ball, instead of arcing down, suddenly speeds upward on its own. To explain it, scientists invoked a new component of the cosmos, an invisible energy inherent in space itself, exerting a repulsive push. They called it dark energy. Today, observations suggest that dark energy makes up about 70% of the total energy content of the universe, with dark matter, another unseen but gravitating substance, contributing about 25%. The ordinary matter that forms stars, planets, and people accounts for less than 5%. We live in a universe whose dominant ingredients are not only invisible, but barely understood. This is the second great paradox. The stage on which everything unfolds is driven by forces we cannot see. The expansion of space, once thought to be slowing, is instead being propelled outward by a mysterious pressure whose nature remains one of the deepest unsolved questions in physics. And because this acceleration stretches space ever faster, regions of the cosmos that were once visible are now being swept beyond our cosmic horizon. Their light, emitted now, will never catch up to us. Imagine a grid drawn on a balloon. As the balloon inflates, the grid squares enlarge, and the dots upon them, representing galaxies, grow farther apart, though they themselves do not move. The distances increase not because the dots travel over the surface, but because the surface itself stretches. Now imagine that the balloon's inflation speeds up. Distant dots soon recede so fast that no signal you send can ever reach them, and no light they emit will ever return. This is what is happening on the grandest scale. The cosmic horizon is not a fixed border, but a receding boundary defined by the race between the stretching of space and the speed of light. With each passing billion years, more galaxies cross this boundary. In the unimaginably distant future, if acceleration continues, only the nearest cluster of galaxies, our own cosmic neighborhood, will remain visible. The rest will fade into darkness beyond a horizon that no telescope, no matter how powerful, can ever pierce. The universe's visible stage will shrink even as the true cosmos continues to expand. The scientific understanding of this dynamic does not diminish its strangeness. We have equations that describe the metric of spacetime, models that predict how expansion changes with time, measurements of redshifts, and supernova brightness that confirm the theory. Yet, beneath the mathematics lies a profound shift in perspective. The edge of the universe is not a wall standing still while we rush toward it. It is a horizon that flees as we advance. We are forever in the center of what we can see, but never at the center of all that exists. This realization adds a poignant twist to our place in the cosmos. The farther we gaze, the further back in time we look, until the galaxies themselves grow young and primitive and finally dissolve into the afterglow of the Big Bang. But even as we gather those ancient photons, the present-day versions of those same galaxies are vanishing beyond our horizon. We observe their youth even as their maturity is lost to us. We are historians peering at the distant past of places whose present and future we will never witness. Here, science brushes against philosophy. What does it mean to live in a universe where most of what exists is not only unseen, but forever unseeable? We are creatures whose understanding thrives on observation. Yet the cosmos withholds more than it reveals. We chase the fleeing edge with our telescopes and equations, knowing that it recedes faster than our questions. Still, this pursuit is not without hope. The traces of the universe's earliest moments remain imprinted in the structure of space and in the background radiation that fills it. By studying those traces, tiny anisotropies in the microwave glow, the distribution of galaxies, the way light bends as it passes invisible masses, we reconstruct the hidden story. We infer the unseen actors from their effects. Like archaeologists unearthing shards of a buried civilization, we gather clues from the observable to glimpse the unobservable. In this light, the expansion itself is not merely a challenge, but also a gift. It made possible the cooling that allowed atoms to form, stars to ignite, planets to congeal. It gave time for life to arise and ponder its origins. The same stretching that carries distant galaxies away from us also carved out the vast epochs needed for complexity to blossom. Without it, the universe would have remained a hot, uniform fog, inhospitable to everything we cherish. Yet the gift comes with an unyielding truth. As expansion accelerates, the cosmic horizon will always define a boundary we cannot cross. It is less like a wall and more like the horizon at sea. No matter how far you sail, the line where the sky meets the water retreats just as far. Always ahead, never at hand. The edge is a mirage born of geometry and motion, a perpetual invitation that can never be accepted. And in that horizon lies the seed of our next questions. What drives dark energy? Did inflation at the dawn of time set the stage for the same kind of runaway expansion we see today? Are there other domains beyond our horizon, governed by the same laws or by laws we cannot imagine? Is the observable universe merely a single bubble in a vast cosmic foam? These questions remind us that the expanding stage is not simply the backdrop of our story. It is an active player, shaping the plot and determining which scenes we can ever witness. As we trace the fleeing galaxies and map the invisible forces, we are not only learning where we are, but also confronting the limits of what we can ever know. The story of expansion is thus both a scientific narrative and a philosophical meditation. It tells of a universe born from almost nothing, swelling to cosmic proportions, driven by forces that remain obscure, and presenting to us a moving frontier instead of a final edge. It leaves us humbled, awed, and curious. We find ourselves on a stage that is still growing, still carrying its actors away from one another, even as the curtain of the horizon draws tighter around what we can see. And so Act 1 closes not with a conclusion, but with an opening. An open question about the nature of the stage itself. We have described its birth and its restless swelling, traced its laws and their strange consequences, but we have not yet stepped beyond it. The next chapters will take us closer to that invisible beyond, to the regions we cannot reach yet suspect are there, lying past the retreating horizon, shaping the play from behind the scenes. There is a horizon we can see, and another we can never cross. The first is familiar to astronomers, the observable limit of the universe, a boundary defined by how far light has traveled since the dawn of time. The second is stranger and more haunting. It is the cosmic event horizon, a deeper frontier set not by time past, but by time yet to come. The observable horizon shows us how far our gaze can reach. The event horizon marks how far our voice, our probes, our very presence can ever go. To grasp these limits, we must start with a subtle but profound distinction. The observable universe is not the whole universe. It is simply the sphere from which light has had enough time to reach us in the 13.8 billion years since the Big Bang. Because space itself has been expanding all along, that sphere is now about 46 billion light-years in radius. Beyond it lies more space, very likely much more, perhaps extending without bound. There may be endless galaxies scattered beyond our sight, their light still racing toward us, but not yet arrived. The particle horizon is the limit of what we can currently observe, the bubble of visibility. But there is a second horizon that owes its existence to the accelerating expansion driven by dark energy. Imagine a galaxy so far away that although we see its ancient light now, the distance between us and that galaxy is growing faster than light today. Any message we send toward it now, no matter how swift, will never catch up. The space in between stretches too fast. That galaxy is already lost to us, not because it has disappeared, but because the fabric of the universe itself is pulling it away faster than our fastest signal can follow. This is the event horizon. In a sense, the observable horizon looks outward to the past. The event horizon looks outward to the future. The first tells us what we can see. The second tells us what we can ever touch. The two horizons are not the same distance away. The observable horizon grows as time passes because new light from slightly more distant regions finally arrives. But the event horizon shrinks in significance. As acceleration continues, more and more galaxies slip beyond it, never again to be in contact with us. Consider the shock of this realization. Of the hundreds of billions of galaxies we can see today, most are already beyond our cosmic reach. Their light, emitted long ago, is only now arriving, carrying images of their distant past. But if we sent a probe or a beam of light toward them today, it would never arrive. We will never know how they evolve, never see their present state, never learn whether civilizations arose there. The universe teases us with their youthful portraits, even as it hides their future from us forever. This creates a paradox almost poetic in its cruelty. The farther we look, the older the images we see, and the less chance we have of ever meeting what we observe. We are like shipwrecked sailors seeing distant lanterns on other rafts. their glow a delayed message of their existence, even as the tides carry them irreversibly away. Our island of communication is finite and shrinking in terms of the fraction of the universe it can reach. Relativity teaches us that nothing moves through space faster than light, yet the expansion of space itself is not limited by that rule. The galaxies are not racing away in the ordinary sense. They are mostly stationary with respect to their local space, but the intervening space stretches. It is as if every square of a cosmic grid keeps enlarging. Objects separated by enough squares see the space between them grow so quickly that even a beam of light cannot bridge it. To visualize this, think of two insects clinging to opposite sides of a rubber band. If the band is stretched slowly, the insects can crawl toward each other and eventually meet. If the band is stretched faster and faster, there comes a point when, no matter how fast they crawl, the distance between them still grows. That is our predicament with distant galaxies. We are the insect, so are they, and the rubber band is the expanding fabric of space. The cosmic acceleration discovered in 1998 sharpened this reality. Before that, we imagined that the whole universe was slowing down, and therefore that distant galaxies, though receding, would always remain in principle reachable given enough time. Now we know that dark energy is driving them apart ever faster. For any distant galaxy, there is a critical moment. Cross an invisible threshold, and it is gone for good. Its light may still arrive for a while, bearing echoes of an era long past, but no future signal we send will ever find it. Astrophysicists can even compute the size of the final communicable region, the last reachable sphere. It extends to a little over 16 billion light-years in proper distance. Everything beyond that is, in a very literal sense, slipping away into permanent isolation. If there is intelligent life in a galaxy now 50 billion light-years distant, we will never know it exists. No greeting, no beacon, no testament of their existence will ever cross the stretching void. The notion of a last reachable galaxy feels like the tightening of invisible prison walls. We live in a universe that grows larger but offers us access to less. The stage on which we act is not just expanding. It is leaving us stranded on a diminishing island of mutual communication. Our cosmic neighborhood will grow ever lonelier. Trillions of years from now, only the nearest cluster of galaxies, gravitationally bound together, will remain visible in an otherwise featureless darkness. The horizons we describe, particle and event, are not like physical shells that could be breached with better engines or bigger ships. They are geometrical boundaries imposed by the dynamics of spacetime itself. Even if we built vessels capable of approaching the speed of light, we would not outrun expansion beyond the event horizon. The obstacle is not technological but fundamental, baked into the structure of the universe. These invisible limits carry a strange psychological weight. To know that most of the universe is forever beyond our reach evokes both awe and a kind of cosmic claustrophobia. We are confined not by walls of stone, but by the very laws of physics. Marooned in a cosmic archipelago where the islands drift apart faster than any messenger can sail. And yet, there is wonder in this knowledge. The horizons themselves are not evidence of smallness, but of vastness. They remind us that what we see is not all that exists. Beyond the faintest galaxies that our telescopes can record lies an ocean of more galaxies, more structures, perhaps other forms of matter and energy, perhaps other versions of cosmic history. The visible universe is like the circle of lantern light cast by a traveler's fire in a boundless dark forest. The forest is still there, even if unseen. Modern cosmology describes these horizons using the language of light cones, a geometric way to chart what events in spacetime can influence or be influenced by others. Every moment of our existence is like a point from which light can spread outward in a widening cone. The past light cone encompasses everything that could have sent light or signals to us so far. The future light cone shows everything that we could ever reach. Cosmic expansion twists these cones in such a way that much of the universe remains outside both. The map of the cosmos is not a simple sphere we can expand into, but a tangle of accessible and inaccessible regions. This structure challenges our imagination. We often think of infinity as a single vast realm, but in an accelerating universe, infinity is divided by horizons. There may be uncountable galaxies beyond our reach, yet their existence is as abstract to us as any purely mathematical infinity. The universe we can interact with, the universe we can, in any practical sense, explore or exchange signals with, is finite, even if the whole is not. The more we learn about these horizons, the more poignant our view of the sky becomes. Every galaxy we see at the farthest edge is like a dying ember, shining with light that left it billions of years ago. We behold it in its youth, even as it has passed forever beyond our touch. The farther the ember, the older its story, and the less chance we have of ever sharing in its present. From a philosophical perspective, this condition reshapes our sense of connection. We are linked not by roads or channels, but by the finite intersection of light cones. Civilization's ultimate boundaries are not the walls we build or the oceans we cross, but the limits of what space-time allows us to influence. Our cosmic island is not merely our planet or even our galaxy, but the shrinking sphere of galaxies that can still exchange signals with us. Yet the human spirit is not easily daunted. We continue to map the visible sky, to chart the receding galaxies, to read the subtle ripples in the cosmic microwave background that hint at conditions beyond our horizon. Even though we cannot reach the farthest shores, we can still glimpse their outline and infer their nature. Like cartographers of an ocean we can never fully sail, we sketch its contours from the waves that reach our coast. The story of the horizons is therefore both a tale of limitation and of discovery. It teaches us that the universe is far larger than our direct experience, that the edge is not a fixed boundary, but a retreating horizon defined by the interplay of light and expansion. It confronts us with the fact that most of what exists is forever beyond our grasp, while at the same time inspiring us to use every photon that does arrive as a clue. There is an unsettling beauty in knowing that we are confined to a cosmic island, even as the ocean beyond continues without end. The prison is invisible, woven of geometry and light, but it is also a window, revealing to us the past of far-off places. We look out and see not the present, but the fossil light of ancient galaxies. We understand that their current state, their possible civilizations, their future fates will remain forever untold to us. And this awareness makes each glimpse more precious, each observation a moment of contact across impossible gulfs. In the end, the horizons beyond sight remind us that we occupy a peculiar position in cosmic history. early enough that we can still see the glow of the primordial fireball and the great web of galaxies, late enough that we know many of them are already slipping away. We live in the narrow window when the universe reveals both its origin and its vastness. Future astronomers in the far distant ages will inherit a sky emptied of all but the nearest stars, the evidence of expansion erased from view. The great horizons closed in around them. Our moment then is rare and privileged. We are witnesses to the full drama of horizons. The particle horizon that marks how far we can see into the past, and the event horizon that foretells how far into the future we can ever reach. We live on a cosmic island illuminated by the lantern light of distant galaxies, watching their glow fade as they slip beyond our reach, knowing that the true edge of the universe is not a wall, but a moving line defined by the race between light and expansion. It is a sobering and yet exhilarating realization that even in an infinite universe, we are confined to a finite domain, that even as the stage grows, the accessible audience and actors diminish. The more we comprehend these horizons, the more we understand that our cosmic story is both grand and intimate, unfolding in a theater that is immense, yet bounded by the unseen limits of space-time itself. This awareness sets the stage for the next question. If there is more beyond these horizons, if the universe continues past our reach into other domains or other realms with their own laws and histories, what might they be like? And will we ever know? Or will they remain forever as distant as dreams beyond a veil of darkening light? There is a question that hides behind every discussion of the cosmic edge. If our observable universe is only a bubble within something larger, what lies outside the bubble? We speak of the Big Bang as the beginning, but beginnings often have prefaces. Perhaps what we call the first moment was merely a chapter break in an older, grander story. The possibility that our entire cosmos is just one domain among many has haunted physics for decades, offering a vision both humbling and strangely consoling. If we are not all there is, perhaps the birth and death of our universe is not the final word. The multiverse is not a single, tidy idea, but a family of speculations, each with its own lineage and motivation. Some arise from attempts to understand why the universe we inhabit has the properties it does, the strengths of forces, the masses of particles, the curious vacuum energy that drives its expansion. Others emerge as side effects of theories devised for wholly different reasons. These speculations differ in detail, but converge on one unsettling suggestion. What we perceive as the totality of existence might be a mere island in an archipelago, or a droplet in an endless foam. Among the most prominent of these ideas is eternal inflation. It is an extension of the inflationary theory that explains the smoothness and structure of our own early cosmos. In standard inflation, the vacuum of space is thought to have been imbued with a peculiar energy field that caused it to swell at a ferocious rate. Then that energy decayed, releasing its contents as radiation and particles, and inflation ended in our region, allowing galaxies and stars to form. But in eternal inflation, this decay never halts everywhere at once. Pockets of the inflating space stop their runaway expansion and blossom into hot Big Bang universes like ours, while elsewhere inflation continues unchecked, spawning more pockets in a never-ending process. Each pocket is like a bubble nucleating in boiling water, with the inflating background as the ever-seething pot. The totality never settles. It keeps giving rise to new cosmic domains. In this picture, our visible universe is simply one bubble among countless others, born when inflation in our region came to an end. Beyond our cosmic horizon, space may still be inflating, endlessly generating new universes. Some bubbles might be similar to ours, others might be wildly different, with different kinds of physics. In some, stars and galaxies might never form. In others, they might form, but with properties alien to our imagination. The constants of nature may differ, making life as we know it impossible, or perhaps opening doors to forms of life inconceivable to us. It is tempting to dismiss such speculations as pure fancy, yet they arise naturally from the mathematics of the theories we already use to explain the early universe. Inflation, as formulated, tends to be eternal to the future, and perhaps even to the past. If it is correct, it almost inevitably produces a multiverse. The question is not whether the idea is extravagant, but whether the physics that predicts it is true. And that, in turn, is a question that we may or may not be able to answer from within our own bubble. Hints, however, have been sought in the faintest patterns of the cosmic microwave background, the ancient afterglow that still bathes our skies. If our bubble had ever brushed against another in the distant past, such a collision might have left a subtle scar, a ring-like pattern in the temperature map of that background radiation. Astronomers have searched for such imprints. A few anomalies have been noted: regions unusually cold or hot, hemispheric asymmetries that resist easy explanation, but none have yet been accepted as definitive evidence of another universe's touch. The cosmic shoreline, if it exists, has left at most a whisper on the waves that reach our detectors. Other visions of the multiverse arise from different lines of theory. In the strange geometry of string theory, for example, our universe might be a three-dimensional membrane, often called a brane, floating in a higher dimensional space. There might be other branes parallel to ours, each carrying its own cosmos. Occasionally, these branes might collide, unleashing energies that resemble big bangs, giving birth to new universes while altering the old. In this Braneworld picture, the true stage of existence is not the expanding bubble we see, but a higher dimensional arena in which bubbles drift and sometimes touch. Still, another line of speculation imagines that black holes may be cradles for new universes. According to this idea, the singularities that form when massive stars collapse might not be final points of destruction, but throats leading to fresh big bangs in regions of spacetime cut off from ours. Every black hole could be a cosmic womb, spawning a separate universe on the other side of its event horizon. Our own Big Bang might have been the end point of such a collapse in some other universe, a phoenix born from another's dying embers. The possibility that black holes could be the seeds of new cosmic domains lends a dizzying continuity to existence. Universes beget universes, each with slightly different properties, and perhaps those more conducive to the formation of black holes reproduce more prolifically. In this way, some theorists have even proposed a kind of cosmic natural selection, a grand evolutionary process in which universes that make more black holes become more common in the multiversal foam. For all these bold ideas, the evidence remains elusive. We are, for now, like sailors in a foggy bay, trying to infer the shape of a vast archipelago from the currents that lap our hull and the faint echoes that return from our calls. Yet, The allure of these ideas lies not only in their potential truth, but in the way they expand our sense of the possible. If we live in one bubble among many, then the cosmic horizon we see is not a final wall, but a shoreline, a boundary between our known waters and a larger cosmic sea. This shoreline is not static. As our universe expands and its acceleration continues, the space between bubbles grows vaster, collisions rarer, communication ever more impossible. We may live forever isolated from our nearest cosmic neighbors, even if they exist. If two bubbles were to collide today, the event would unfold at nearly the speed of light. We would not see it coming until its shock front arrived. Our fate would be sealed long before we could even recognize the threat. The very thought adds a tinge of dread to the cosmic foam, as if we were inhabitants of a fragile soap bubble, afloat in an ocean where other bubbles sometimes burst and merge. This fragility challenges our intuition. We imagine the universe as a solid, enduring thing. Yet in these theories, it is merely one transient region in a larger, dynamic froth. The edge we can see, marked by the fading light of distant galaxies, may be only the inner shore of our bubble. Beyond that lies an uncharted expanse, perhaps eternally inflating space, perhaps higher dimensions, perhaps the interiors of other cosmic embryos. The known cosmos is not the final container, but the local district in an infinite archipelago. From a philosophical standpoint, this vision reshapes the question of origin. If the Big Bang was not the absolute beginning but a transition, a local flare-up within a larger eternal process, then the mystery shifts from "why was there something rather than nothing?" to "why is there this process at all and what sustains it?" The stage grows wider, and so do the questions. It also reframes the meaning of the word edge. We have learned that the edge of the observable universe is not an end but a horizon. We now imagine that the horizon itself may be only a beach at the border of an unseen ocean. If we could somehow pierce that horizon, we might not find empty space, but other worlds with other histories. We might discover that our cosmic story is just one volume in a vast and growing library. The idea is as exhilarating as it is unsettling. It suggests that our entire observable universe, with its billions of galaxies, each containing billions of stars, is just a parochial neighborhood, a single bubble among perhaps infinite others. It reduces our grandest scales to the status of a local eddy in a larger current. Yet it also offers a kind of comfort. If creation and destruction are ongoing on scales beyond our own, then the rise and fall of our universe is not a unique tragedy, but part of a deeper cosmic rhythm. These speculations, while grounded in serious physics, inevitably blend into philosophy. We cannot test them directly, at least not yet. We can seek subtle clues, like ancient scars in the microwave background, like gravitational waves from collisions of cosmic bubbles, like unexplained patterns in the distribution of galaxies. But we cannot now step outside our bubble to look back at it from the outside. We are like fish in a pond, trying to imagine the ocean beyond its banks. And perhaps that is the enduring lesson of the multiverse idea, that every edge we perceive may be a local illusion, a limit of perspective rather than of reality. For centuries, humans thought the stars marked the outer sphere of creation. Later, we thought our galaxy was the whole. Then we learned that galaxies fill the sky by the billions. Now we contemplate the possibility that even this vast expanse is only a single bubble in a foam that stretches without end. If that foam exists, it makes the universe both more alien and more intimate. We might be related, however distantly, to other worlds born in the collapse of alien stars or the collision of unseen brains. We might be part of an eternal lineage of universes, each giving rise to the next. Our cosmic genealogy would reach beyond the Big Bang, tracing back through a chain of ancestral universes, each linked by the laws of physics that govern their births and deaths. And so we come to a new kind of edge. Not the visible rim of the observable universe, not the horizon set by accelerating expansion, but the conceptual edge of understanding itself. We have followed the thread of cosmic history back to the first fraction of a second, and we have traced the implications of physics beyond even that. Yet, the nature of the larger multiverse remains hidden, perhaps forever beyond empirical reach. We stand on the shoreline of comprehension, watching waves lap at the sand, hearing in their rhythm the suggestion of deeper oceans. In contemplating other universes, we are not merely indulging imagination. We are acknowledging the reach of the questions that the cosmos itself compels us to ask. We are admitting that the true beginning may lie beyond what we call the beginning. And as we ponder this possibility, another door opens. If universes can bud from black holes, if each collapse can be the seed of a new expansion, then perhaps the final fate of our own cosmos, whether by heat death or gravitational collapse, is not the end, but the genesis of another world. This thought is at once terrifying and profound, that black holes, which we have long seen as the ultimate destroyers, might also be the ultimate creators. In their hidden depths, beyond the veil of the event horizon, the laws of physics may reorganize, birthing new space and time, new matter and energy, new possibilities. The death throes of one universe may be the labor of another's birth, and so Act 3 closes on a cliffhanger. The edge of our observable world may not be the outer rim of reality, but the inner boundary of a bubble. The Big Bang may have been a local flare in an eternal sea of inflating space, or the rebound from a collapsing star in some ancestral cosmos. The black holes we fear as cosmic abysses may be gateways to new beginnings. We have followed the horizons beyond sight to their conceptual limits, and found there not an end but an invitation to imagine that creation itself is an unending story of bubbles in a restless foam, each with its own dawn and its own unseen shores. There is a quiet tragedy written into the future of our sky. We often imagine that time will reveal more to us, that patient observation will expand our knowledge as steadily as our telescopes expand their reach. Yet the ultimate fate of the universe tells a different story. As the cosmos grows older, the horizons that have defined our view will begin to betray us. Not by closing in, but by slipping away. The universe will keep expanding, yet the portion of it we can see, and, still more, the portion we can influence, will grow ever smaller. The first sign of this future is already inscribed in the light of the galaxies we observe. Those farthest away are not merely distant in space, they are distant in time. We see them as they were billions of years ago, because that is how long their light has taken to reach us. But while their ancient glow still travels toward our telescopes, the present-day versions of those galaxies are receding ever faster. As the expansion of space accelerates, more and more of them cross the cosmic event horizon. Their new light, emitted today, will never reach us. We see them fading into redder hues, like the last embers of a far-off fire, but we will never witness their next chapters. In perhaps 100 billion years, a blink compared to the full lifetime of the universe, only the galaxies bound to us by gravity, those in our local group, will remain visible. The great cosmic web that now stretches across our view, with its filaments of light connecting distant clusters, will appear to unravel strand by strand, one by one, like ships slipping over the horizon of an endless sea. The remote galaxies will vanish, their signals swallowed by the accelerating expansion. For any civilization that may exist in such a far future, the universe will seem smaller, lonelier, and more deceptive. Without the evidence of receding galaxies and the cosmic microwave background to guide them, their astronomers may never suspect that the cosmos is expanding. The sky will appear as a static archipelago of a few galaxies surrounded by infinite blackness. The grand history we now reconstruct, the story of the Big Bang, the rise of galaxies, the acceleration driven by dark energy, may be forever hidden from their view. The universe will have veiled its own origins. This prospect is not merely a curiosity for distant descendants. It reveals something deep and paradoxical. As the universe grows larger, our horizon of knowledge shrinks. The more the cosmos expands, the less of it remains accessible to observation. The boundless future carries with it a growing blindness. In a universe that seems to promise infinity, we find ourselves destined to inhabit an ever-contracting island of awareness. And what of the deeper fate of that future island? Here science must peer forward across incomprehensible stretches of time, using the laws we know as guides, yet accepting that they may themselves evolve. We can sketch a handful of possible destinies, each strange in its own way, each shaping the fate of the shrinking horizon. In the most widely accepted scenario, dark energy persists as a constant property of space, and the universe expands forever. As expansion continues, galaxies move beyond reach, stars burn out, and new stars are no longer born. The era of brilliant galaxies gives way to a long twilight, dominated by faint red dwarfs and cooling white dwarfs. Over trillions of years, even those gutter out, leaving behind only dead remnants. Black dwarfs, neutron stars, black holes, drifting farther apart in a cosmos growing ever colder and darker. This bleak future is known as heat death, a state in which the universe approaches thermal equilibrium, no longer able to sustain the flow of energy that powers stars, planets, and life. Entropy increases relentlessly, smoothing out all gradients of temperature, all sources of usable energy. In such a future, the very concept of a horizon becomes almost moot, for nothing remains to send light or signal across it. But there are more dramatic alternatives. If dark energy is not constant but grows stronger over time, its repulsive effect could intensify until it overwhelms even the forces that hold galaxies, stars, planets, and atoms together. This fate is called the Big Rip. In that scenario, the accelerating expansion not only drives galaxies beyond sight, but eventually tears apart the structures of matter itself. Stars would be shredded, planets dissolved, even molecules and atoms ripped apart as space expands with runaway ferocity. The cosmic horizon would not just recede but sweep inward, erasing the familiar universe in a final catastrophic unbinding. There is another possibility, equally haunting in its own way, that the vacuum energy we call dark energy is not eternal, but metastable, like a false floor beneath the universe. If it were to decay to a lower energy state, a bubble of new vacuum could form somewhere in the vast expanse and expand at nearly the speed of light, converting all it encounters into a new phase of reality. Such a transition would end the universe we know, replacing its physics with new laws, perhaps initiating a new Big Bang of its own. We would never see it coming. The signal of its approach would arrive with the catastrophe itself. And yet, there are even more speculative hopes. Some theories of quantum gravity suggest that the expansion we see may eventually reverse, or that the universe may pass through cycles of collapse and rebirth. In these scenarios, the horizon we now fear as a permanent boundary might one day be transcended in a new beginning. The end of one cosmic chapter could seed the birth of another, perhaps even in the depths of black holes, as Act 3 suggested. If so, the fading of our horizon would not be the last word. Whatever the ultimate fate, one truth is clear. As time advances, the universe's long-term tendency is toward isolation. Any future civilization, no matter how ingenious, will find itself confined to a smaller and smaller sphere of influence. The expansion of space is not a force that can be countered by rockets or even by hypothetical faster-than-light drives, for it is not an ordinary motion to be overtaken. It is the stretching of the stage itself. This cosmic isolation has profound implications for the persistence of information. Every galaxy that crosses the event horizon takes with it an untold library of histories, unique records of how its stars and worlds evolved, how life may have arisen there. That information will become inaccessible to us forever, as if entire chapters of the Universal Chronicle were torn from the book and cast into the void. The horizon is not merely a limit on travel, but a veil over memory itself. From a human perspective, there is something unbearably poignant about this prospect. We look out at the night sky and feel we are seeing eternity. In truth, we are looking at a temporary phase in the life of the cosmos, a fleeting moment when the universe is still richly illuminated, still revealing its story. The grand tapestry of galaxies that fills our telescopes today is destined to unravel and fade, leaving behind a sparse sky in which the memory of cosmic origin is almost impossible to reconstruct. This realization casts our own era in a new light. We live at a time when the universe is large enough and transparent enough to show us its vastness and its beginnings, yet not so old that the evidence has vanished beyond reach. We are privileged witnesses at the midpoint of revelation, catching the cosmos in the act of both expanding and still disclosing its past. Future astronomers may gaze into a night sky devoid of clues, seeing only the nearby stars and assuming that nothing else ever was. Such reflections evoke a subtle dread, cosmic loneliness on a scale beyond personal or cultural isolation. They also invite a kind of humility. The universe does not exist to be observed by us. Its great drama plays out whether or not there are eyes to watch it, and the stage does not pause for its actors. That we find ourselves living at a time when the grand panorama is still visible may be an accident, but it is an extraordinary one. And yet, even as the horizon shrinks, the edge we fear is not the final edge. The visible universe is only a chapter, and the horizon a shifting line. Beyond it, other galaxies continue their own stories, unseen by us, but no less real. The universe's vastness remains, whether revealed to our gaze or hidden by expansion. Our isolation in the future will be real, but it will not mean that the rest ceases to exist. The fate of our horizon therefore holds a paradoxical lesson. The universe's growth does not ensure the growth of knowledge. In the long run, it enforces forgetfulness, casting most of its own history beyond recall. Yet that very loss reminds us that the present is precious. The cosmic night is still young enough to be bright with distant galaxies, still strewn with clues to its origin. We are fortunate to live in this rare window of time when the horizon is wide and the evidence abundant. To contemplate the distant future is to feel a quiet awe mingled with a deep melancholy. We envision a universe where the lights of the galaxies have sailed beyond reach, where the sky grows dark and silent, where entropy steals the last gradients of energy, and where perhaps the very fabric of space-time tears itself apart. But the final truth is more humbling still. The edge we perceive has never been the true edge. It has always been a horizon, a mirage born of light and time and expansion. As we face the prospect of a shrinking horizon, we can take some solace in knowing that horizons are not walls. They are boundaries of perception and influence, not of existence. Beyond them, the cosmos carries on in ways we can never know, like ships sailing away into a night sea whose waters do not end. The story continues even when the storyteller's voice can no longer be heard. And perhaps, in that recognition, there is a spark of hope. For if the universe's long future hides its history from view, it also preserves the mystery that has always driven us to look outward. The horizon, even in retreat, still beckons. It reminds us that knowledge is never complete, that discovery is always finite and precious, and that the edge we can see is never the end. Act 4 therefore leaves us with an image at once somber and profound. Galaxies like glowing vessels sailing over the darkening horizon. The ocean of space widening even as our circle of light grows smaller, and the travelers within that circle aware, perhaps for the first time, that their horizon was never the universe's edge, only a passing frontier in an unending story. We began by calling it an edge, as if the universe were a vast terrain with a distant border, a far rim to be approached like the crest of a mountain or the shore of an ocean. Yet the deeper we have probed with mathematics, telescopes, and imagination, the more that image has dissolved. The edge recedes, transforms, loses substance. It becomes a horizon, always ahead, always moving, never a final wall. Now, at the end of this journey, we confront a stranger and more liberating possibility, that the edge may be less a limit than a beginning. For centuries, we have sought origins in moments, a first spark, a sudden creation from nothing. The Big Bang itself has often been pictured as such a singular birth. But as our theories of gravity and quantum fields have grown subtler, that tidy picture has frayed. We are beginning to suspect that what we call the beginning might have been a transition, a passage from one state of reality to another. If that is so, then the edge is no longer an abrupt cliff where everything falls off, but a seam where one kind of space-time gives way to another. Some of the boldest models imagine the universe as part of an endless cycle. In these scenarios, expansion does not go on forever, but eventually slows, halts, and reverses, leading to a collapse,
a big crunch, followed by a new big bang.
The cosmos oscillates through epochs of birth, growth, decline, and rebirth. Each cycle erases most of the memory of its predecessor, but may carry subtle imprints forward. In such a universe, the edge of our beginning is not absolute. It is a turning point in an unending rhythm. Other ideas come from the strange marriage of quantum theory and gravity, a union still incomplete, but suggestive. Quantum cosmology hints that space-time itself might have emerged from a more primitive quantum state. Something not quite space, not quite time, but a seething probability field from which our familiar dimensions condensed. In that picture, the edge is not even a transition in the usual sense. It is a change in the very language of existence. Asking what came before may be like asking what lies north of the North Pole. The question itself dissolves at the limit. Another vision proposes that the boundary of the universe is not a spatial frontier but a holographic screen. In certain formulations of string theory and gravity, the three-dimensional world we inhabit may be describable as information encoded on a two-dimensional surface at its boundary. If this holographic principle holds, then the edge we imagine as the farthest reach of space may actually be the deepest foundation of reality, a cosmic horizon from which the patterns of matter and energy unfold like the image projected from a screen. In this interpretation, horizons are not merely limits of sight, but fundamental sources of the world we experience. These are speculative ideas, but they share a common theme. They suggest that the universe's edges, whether in time, space, or perception, are not final barricades. They are thresholds. Crossing them in thought or theory leads us not to nothingness, but to a new domain of description, a deeper layer of the cosmic story. The edge is where our old concepts fail and new ones are born. To the human mind, raised on journeys across landscapes, horizons have always promised more land beyond. In cosmology, horizons have proved both more deceptive and more profound. They do not hide mere geography, but changes in the very rules of existence. And yet, they continue to evoke the ancient intuition that beyond the line we see lies something else, waiting. Emerging physics offers hints that such intuition may be right in more than a metaphorical sense. Some models of inflation suggest that new universes can bud off from the quantum fluctuations of space-time itself, sprouting like foam at the edges of inflating space. In this picture, what looks to us like an ultimate horizon may, from another vantage, be the nursery of new cosmic domains. The universe begets universes, each horizon a cradle of new beginnings. The idea that edges can be beginnings also arises when we contemplate black holes. As we have seen, these regions of space-time, where gravity crushes matter to extremes, may not be mere graves. Some speculative theories suggest that a black hole's singularity may open into a fresh region of expanding space on the other side, a new universe budding from the collapse of old stars. If so, then every black hole in our cosmos may be a doorway. And perhaps our own Big Bang was such a passage, the rebirth of space-time from the death throes of a prior world. Even if these conjectures prove incomplete or mistaken, they reveal a profound shift in our outlook. We no longer see the edge as a hard border that separates being from nothing. We begin to sense it as the threshold where our familiar categories fail, where new descriptions, new laws, new realms may emerge. In that sense, the ultimate frontier is not out there in distance, but here in understanding. To reach it is not to travel farther, but to think more deeply. This realization reframes the quest for the edge. We have sent telescopes to the farthest reaches of light. We have mapped the afterglow of the Big Bang. We have inferred the structure of the universe billions of light years away. Yet the final mystery has not yielded to distance. It resides in the nature of space and time themselves, in the quantum foundation beneath the cosmic expanse. The farther we look outward, the more we are led inward, to the very rules that make horizons meaningful. In this light, the old paradox of the edge dissolves into something more hopeful. The ultimate boundary may not be the perimeter of our cosmos, but the limit of our comprehension, a limit that can shift as our knowledge grows. To confront it is to face not a final wall but an invitation to deeper insight. What appears as an ending may be the beginning of a new understanding. Philosophically, this invites a humbler and more expansive vision of our place in reality. We may never grasp the whole of existence, but we can continue to widen the circle of what we know. Each horizon reached, each new telescope's image, each equation refined, reminds us that the unknown is not empty, but fertile. We find that mystery is not a void, but a generative depth from which new questions arise as fast as we answer the old. Perhaps that is the true meaning of the cosmic edge. It is the line where our current story ends and another begins. It is not a finish line, but a frontier that retreats as we approach, carrying us forward into new realms of thought. As long as there are edges to chase, there will be beginnings to discover. Imagine standing once more on the notional shore of the observable universe. Before you lies the darkness beyond the cosmic horizon. You know now that the darkness is not nothingness. It is the unlit continuation of the cosmic ocean. Somewhere out there, perhaps, other bubbles are forming. Other beginnings are unfolding. Perhaps even in the distant future, when our own horizon has shrunk to a lonely handful of galaxies, the broader cosmos will still be alive with unseen births. The image shifts as you look closer. The horizon, once a line, wavers and dissolves as if made of light itself. It folds and curves, becomes not a boundary but a wave crest, a ripple in a vast continuum. Beyond it, one cannot say whether there is more space or a different kind of being altogether. But the intuition remains. The edge is not the end. From this vantage, the entire arc of cosmic history, the inflationary burst, the formation of galaxies, the acceleration that carries them beyond sight, can be seen as a single phase in a larger, perhaps endless, process. The universe is not a lone firework that bloomed once in the void. It is a flame that may have been lit before and may ignite again, each horizon a spark breaking into new fire. In coming to the edge, we have come to understand that the greatest frontier lies not in the stars we cannot reach, but in the frameworks we have yet to conceive. The quest for the edge has revealed the boundlessness of beginnings. It has shown us that each limit we meet, whether in space, in time, or in knowledge, can be the threshold of a new domain. So we end where we began, with a paradox. The edge of the universe, which once seemed like a final boundary, turns out to be a doorway. The horizons that confine our sight are also the places where new worlds may arise. The farther we journey outward, the more we find that the ultimate journey is inward, toward deeper laws, deeper connections, deeper wonder. And as we stand at that shifting boundary of understanding, we feel a renewed awe. For the edge is no longer a distant rim in the sky. It is the very frontier of comprehension. To approach it is to discover that the story is never finished. Each horizon reached opens onto new horizons. Each ending reveals another beginning. In this recognition, there is hope as well as humility. The universe may not offer us final answers, but it grants us endless questions. Its edges dissolve into invitations. And so, even as we contemplate the long night ahead, the shrinking horizons and the eventual silence, we can hold to the thought that every apparent limit is a threshold of discovery, every ending the dawn of a new domain. Picture, at last, the cosmic horizon dissolving into a luminous mist, as if a night sky of scattered stars were melting into a soft, all-encompassing glow. Out of that glow rises a new wave of creation, folding back upon itself, rolling forward into a future we cannot yet imagine. The edge is not a wall, it is a tide. And with each tide comes a new beginning. We have followed the edge of the universe outward through expanding horizons, imagined its birth in other realms, traced its possible futures to fading lights and silent nights. Yet, as the story draws to a close, the gaze turns inward, back to the fragile beings who first looked up at the stars and wondered. For the edge is not only a line written in space-time, it is also a question carried in us, a tension in our minds that refuses to rest. We are the part of the cosmos that asks what lies beyond. Perhaps that impulse, more than any distant galaxy, is the universe's most astonishing frontier. The story of this impulse began in simple acts. A hand raised to shield the eyes from the glare of the sun. The first marks scratched on stone to record the phases of the moon. With each tool we built, lens, telescope, detector, we pushed our vision outward, turning the night sky into a map of history. The great observatories of our time have gathered light from galaxies whose glow began its journey before the Earth was born. The James Webb Space Telescope peers so far back in time that it shows us galaxies forming in the dawn of the cosmos. Each such instrument is a new kind of eye, an extension of curiosity, widening the circle of what the universe can know of itself. We live in an age when our machines orbit distant planets, wander the frozen frontiers of our own solar system, and listen for faint pulses of gravitational waves, ripples in the fabric of space that carry news of colliding black holes billions of light years away. These endeavors are not merely technical feats. They are acts of attention, of the universe noticing its own story. In every observation we make, some part of the cosmos awakens to itself. Yet the edge we pursue has always moved ahead of us. We stretch our instruments to greater sensitivities, launch them to higher vantage points, and still the horizon recedes. We discover not a final wall, but further mysteries. We are, and may always be, creatures at a threshold, never at the center, never at the end. This unending chase is not a failure. It is the nature of knowledge. It is also the source of our awe. For in knowing that there is always more to seek, we sense the boundlessness of reality. The pursuit has transformed us. Once we looked up at the stars with the fear that the heavens were fixed and eternal, beyond change. Now we know that everything changes. Stars are born, burn, and die. Galaxies gather and drift apart. Even the fabric of space evolves. The edge we strive to reach is not a frozen limit, but a moving wave. This recognition has taught us humility, yet also given us courage to ask deeper questions. Perhaps the next leaps will come not from larger telescopes alone, but from new ways of thinking, new mathematics, new physics, new forms of intelligence. The universe's questions may outlast the species that first began to pose them. One day, the minds asking, "What lies beyond?" may not be human. They may be descendants of our machines, or of life evolved in distant worlds, or something yet unimagined. The torch of curiosity may pass to other hands, other eyes, other kinds of awareness, and still the question will burn. Where is the edge, and what lies past it? This thought can be unsettling, but it also offers hope. The quest for understanding is larger than any one civilization or one kind of being. It is a thread woven into the fabric of thinking life itself. To wonder is to reach outward, and to reach outward is to keep alive the dialogue between the cosmos and itself. In a sense, each generation stands at its own threshold. The astronomers of antiquity, who charted the wandering lights and discerned the first laws of motion, were pushing the horizon as surely as the builders of space telescopes do today. The difference lies not in the spirit of inquiry, but in the scale of the tools. The urge to know what lies beyond is a continuity that binds us across centuries. It is the universe, through us, stretching its vision further. Even now, as we face the knowledge that most of the cosmos will slip beyond our reach, we continue to reach outward. We build detectors to catch the faint glow of the first stars, search for exoplanets that might harbor life, study the subtle distortions of distant light that reveal the distribution of invisible matter. We do these things knowing that each discovery is provisional, that every answer opens new questions. We persist not because we believe we will find a final edge, but because each step reshapes our understanding of what beginnings mean. There is a quiet heroism in this persistence. Against the backdrop of a universe that will one day hide its story behind a receding horizon, we continue to gather its light while we can. We know that our time as witnesses is brief, that our island of awareness is temporary, yet we choose to look outward. We choose to make the most of this rare moment in cosmic history when the sky is still bright with distant galaxies and the echoes of the Big Bang still hum in the background. If we seek meaning in this vast story, perhaps it lies here, in the act of seeking itself. The edge of the universe is not merely a feature of space, it is a measure of our readiness to ask what comes next. Our curiosity may be the true frontier, the spark that keeps the story alive. In every question we ask, the universe grows a little more aware of itself. We may be brief, but in this briefness we carry forward a conversation as old as the stars. Imagine, for a moment, a distant future when the Milky Way has merged with its neighboring galaxies and the rest of the cosmos has faded from view. A lone observer, human or otherwise, stands on a world beneath a sky of nearby stars, the rest of creation hidden beyond the horizon of expansion. Perhaps that being will still feel the ancient urge to wonder, to ask what lies beyond the circle of light. The answers may be harder to find then, the evidence too faint, but the question itself will remain. It will be the ember that endures when the great fires have dimmed. In that sense, The edge is less a line in the heavens than a quality of mind, a readiness to reach, to imagine, to seek. The universe has given rise to countless stars, but only rarely to beings who can look back at it and ask what it means. We are among those rare sparks. Our instruments are the eyes we lend to the cosmos. Our questions are the voice by which it wonders about itself. As we close this journey, picture the reflection of human eyes in the polished lens of a telescope. In that reflection lies a distant galaxy, its light traveling across eons to meet the gaze of a creature who has only just learned to question. That image captures the essence of our place in the story, the meeting of the infinite and the finite, the vast and the fleeting. It is a reminder that the quest for the edge is as much about us as about the cosmos. The edge, we have learned, is not a wall to be struck, but a threshold to be crossed in understanding. And the crossing is never finished. Every horizon reached opens onto another. Every answer reveals deeper questions. The story does not end at the edge. It begins there, again and again, in the minds that dare to look beyond. Perhaps this is the most hopeful truth of all, that as long as there is curiosity somewhere in the cosmos, whether in human hearts, in the minds of distant beings, or in the awareness of future intelligences, the quest will continue. The universe will keep asking itself what lies beyond its own horizons. And in that endless asking, in that reaching across the shifting thresholds of knowledge, the edge will always be the beginning.